is Megan Jones, and today I'm going to be talking to you guys about how to troubleshoot like a next generation firewall engineer. But we're going to specifically be focusing on how to troubleshoot traffic problems within your network. So I do want to start out with a question. How many of you guys have experienced some sort of traffic problem with your firewall? I would assume almost everyone. So I've taken around 3,000 cases on my team, and one of the most popular cases we have is traffic problems. And this could range from like interface routing is not working appropriately, or maybe your access list is blocking, or even like a NAT translation is not doing what you want. So today I want to walk us through some of the initial troubleshooting process that TAC does to troubleshoot these problems. So let's begin, guys. I want to start with the agenda, because today we're not only just going to be talking about this, but I want you guys to be involved too. So I'm going to set the scene. We're going to have a scenario, so that way all of us can get our detective caps on, and we're going to be investigating a traffic problem together. With that, a topology is super important with any traffic problem. This is going to show us what's between us and where we're trying to go. So we're going to make sure we show up a samples topology of our scenario. Afterwards, we're going to discuss the three main tools that TAC uses to do traffic problems. This is going to be packet tracer, packet capture, and system support trace. With these three tools, we're going to discuss how to configure them, when to use them, and what they look like output-wise. Then we're going to take all of that together, we're going to wrap it up, and we're going to go back to the scenario and show you guys outputs of what might be going on with our traffic. Lastly, I want to discuss next steps of how this benefits you guys as customers. At the end, if we got time, we're going to do some questions. Let's get to it. So, I don't know, who's first time at Cisco Live? Anyone in the audience? This is awesome, my first time at Cisco Live. So when I heard I was going to Cisco Live, I was beyond excited. It was like a dream come true. I never thought that I would be here in San Diego too. I've never been on the West Coast before. So when I'm the type of person that likes to plan out my schedule too. Like day to day, I got 4 days, not a lot of time, gotta like really pack it in. So I go to my workstation and I type in cisco.com to navigate to see what the schedule looks like, and I face with a connection timeout. So that's like instant defeat. This is like destroys all my excitement I have, because now I'm annoyed and I'm like, why can't I get to the internet? But we gotta push all that annoyance aside and we gotta figure out what's going on. So as stated before, it's important to know your topology. So this is our sample topology here. So my workstation has the IP of 192.168.0.11. We're connected to the firewall through the inside interface, and we're leaving through the outside interface to connect to the cisco.com. In this scenario, I just did an NS lookup on Cisco's IP because it's a static IP, so that's how I got the 72.163.4.161, which it makes it a really good IP to troubleshoot if you guys are having like 443 traffic problems, because it's static. So now that we kind of went through this, you might be asking, how do I know it's the inside or the outside? I only know that my inside is Ethernet 1/1. Well, good news is that we could do a command called show route. So I could do a show route on my workstation, and I could see to get to my workstation, we are directly connected via the inside interface. So the reason why we want to get these logical names is these logical names will help us configure the tools later. So I want to go ahead and gather all that information now, so then when we start building the tools out, we don't have to reference back. So now that we got the inside interface, how did I get the outside interface? So let's do show route on Cisco as IP. When we do that, we get network not found in the table. So what does that mean? I mean, how do I know where I'm going? Well, because we are going out to the internet, this is going to use my default gateway. So if I did a show route on 0.0.0, I can see that any of my traffic that's going out to the internet is leaving out of my default gateway of 128.107.0.1 via the outside interface. So all this information is super helpful to help get an idea of how my traffic's flowing, so we can go on to the next step to the troubleshooting. So since we got these, let's move to our first tool, and that's going to be packet tracer. Packet tracer is going to be a virtual packet that's going to show you like a simulation of the packet's life through the firewall. So this is kind of a very rough diagram of what that's going to look like. It's going to be broken down in different phases that you'll see, such as like access lists, NAT. You'll see things like VPN, which we could talk about that in the next slide. Important thing to know, though, is that packet tracer, super helpful, because if you can't currently troubleshoot that live, this is just a simulation. So we could do this if we can't actually have someone on site testing this traffic. Now, because it is a simulation, it is important to note that it's not real data transversing through the data plane. So yes, it does fit a lot of scenarios. It doesn't fit every scenario. So it's important to not just stop on this tool. We're discussing 3 tools today. So we don't want to stop at step 1. We want to do all 3 steps so we can see the full picture of what's going on with our traffic. So a good thing with this too is that it can be configured in Clish and Lena, which means anyone out there who's just running an ASA image, this command is available for you too. So for people who might not know what Clish and Lena mean exactly, Clish is going to be that initial CLI when you log onto your firepower device. It's indicated with the greater than symbol there. And then Lena is going to be where our ASA image sits at. So for ASA image devices, that's the only CLI you have access to. For firepower devices, you access Lena with the system support diagnostic. From there, you hit enable, and then you can configure your packet tracer from there. So as discussed, I want to briefly touch on some of the phases. For this specific presentation, we're really only going to focus on phase 3 and phase 5 and the results tab. However, I do want to make sure we understand that this is kind of just a rough summary of all the phases you can see. I've seen up to 32 phases before. This is just from my lab device. If you notice here, phase 11 is failover. So if you're running a single unit device and not an HA, you will not have a failover phase. So you may have more phases or less phases depending on what features you have enabled. Like VPN could be a whole nother phase in here, but I don't have VPN configured on my lab, so it's not going to show up there. It's also important to note that you will not get all the phases if it fails. So let's say our NAT translation is not correct and we fail on phase 7. We will only get the first 7 phases and the results tab. Though the results tab will kind of give us an indication of why we failed at that phase 7. So now that we kind of got a good brief understanding of packet tracer, let's configure it together. So packet tracer is always going to start with that packet tracer input. I'm going to pull up our topology to have that as a reference guide, so that way as we're configuring together, we can have that as a reference. So we're going to start from the source interface. This is where my workstation is located at and how it's connecting to the firewall. So in this scenario, we're connecting through the inside interface, so our source will be inside. Next, we're going to do protocol. Our protocol is going to be TCP because we're doing an HTTPS connection. Following that is going to be the source IP. And in this scenario, source IP is my workstation. Moving forward, we are going to do our source port. So because this is a simulation, the source port doesn't totally matter. If you don't know it immediately, that's fine. I don't know my direct source port, so I'm just using 5 5s. But if you know your source port, even better, put it in. But because, once again, this is a simulation, put whatever numbers here you would like. Next, we're going to do our destination IP, which is still going to be Cisco.com's IP. And then following that, we're going to do our destination port, which is 443, which is associated to HTTPS. So when we take all of that information and we plug it into our command, it looks a little something like this. And this is why I say the topology is super useful, because if you have a good layout similar to this, it's a lot of dragging and dropping and putting in where you need to be able to form your command perfectly. So now we got packet tracer. Let's do packet captures. So packet captures are live traffic across the network, meaning if you don't have someone there to troubleshoot it and simulate the problem live, this is not going to help us at all. We need someone who can make the error happen with your traffic so we can see how the traffic's flowing within your network. Captures sit on actual interfaces and grabs packets as they come through. This could be run in Clish and Lena, just like packet tracer. So ASA image devices, you can also run this. There are 3 main types of packet captures that TAC does. And this is going to be the ingress, which is packets that are coming into the firewall. This is egress, packets leaving the firewall. And then we have ASP drop packets. ASP drop packets sorry, ASP drop packets are any packets that are purposely dropped by the firewall. This is going to be things like access list, block listing by snort, or it could be like interface down. So a good way to kind of figure out different ASP drop packets is on your actual firewall, you can do like a show ASP drop, and it will show you all the most popular ASP drops specifically to your device. And it just kind of gives you a good idea of what type of traffic is getting dropped on your firewall. So I want to pull up this diagram again just for a good visual. Wherever you see those orange arrows at, that's where your packet is sitting, and that's where it's reading at. So as packets enter through those phases, that's what it's getting documented within the packet capture. So I do want to configure it in two separate things. So we're going to start with the ingress and egress breakdown first, and then we'll move to our ASP drop ones. So for this specific packet capture, we're going to do IP to IP. I do want to note that there's so many different packet captures you could do, and I probably could spend the whole 30 minutes, if not like 2 hours, talking to you guys about all these different packet captures you could do. But we're just going to do an IP to IP. I know we could technically here do port-based because we know we're doing 443 traffic, or we could do TCP because this is all TCP traffic. Or, I mean, in general, there's so many different packet captures. But because I know my source and destination, I'm going to leave it like that. Now, a good scenario is if you don't know what your destination is, you could always do like an IP to any, or let's say that the network you're connecting to is dynamic and the IP is always changing. You could do an IP to a network range as well. So all those are different packet captures that are super helpful, and you can always use the question mark feature to kind of build a command that works best for your environment. So we're gonna pull up a topology again, and I'm gonna pull up our capture. The most important thing in every packet capture is the name. You want it to be clear enough that you understand what you're looking at, but also note that there's no tabbing this out. So when you do show cap, you have to type out every letter you write. And I don't know about you guys, but I'm not always great at typing, but I can type 2 letters really well. So IN for my ingress is perfect because this is captures that are entering to the inside interface of the firewall. These are my in packets. These are the ones entering. So off of that, these are gonna sit on the inside interface. From there, we're gonna match our IP to be my source, and then my destination, which is gonna be Cisco's IP. These packets are bidirectional, meaning that as the packets return with replies, it will also get documented in here. Also meaning I could switch those IPs and I would get that same information. Next, we're gonna do our egress. So we're gonna pull up our topology. Very similar name-wise, I could type 3 letters just as well, so that's out, so packets leaving the firewall. And then this is also going to sit on the outside interface. And some of you who are reading ahead might be like, oh, Megan, you have a typo. That's a weird IP. I've never seen that IP before. But it's not a typo. This is purposeful. Because this is traffic that is leaving the firewall, we cannot use our private IP because at this point, we have gone through NAT translation. So when we are sitting on that outside interface, any private IP that you might have will not be seen anymore. So if I was to take a capture with that 192 IP, I would see nothing, and I would think there's something wrong with my traffic. I mean, obviously right now there's something wrong with my traffic, but we want to make sure we capture with that public IP. And there's a reason why I told you guys to do packet tracer first, because not a lot of people immediately know what their NAT translation IP is off the top of their head. I didn't know mine when I was configuring it in the lab. But with packet tracer, that phase 7 on my packet tracer will tell me exactly what my NAT translates out to be. So this is why I always tell people to run packet tracer first, because you can get all the information you need to be able to help do your captures when you're doing the live test. So our destination for this one is still going to be cisco.com. So now that we covered our public and private, we'll go ahead and move on to our ASP drops. With our ASP drop captures here, we do not set them on a specific interface. ASPs are very argument-based, where it's just going to match whatever argument we put. It doesn't sit on an interface. So we're just going to pull up our topology again, and we're going to make the name cap ASP, straight to the point. I know this is an ASP drop capture, and we're just going to match my source to my destination. Now with this, what if the packet's getting dropped on the return? My private IP is not going to get captured in here. And at this point, we don't know what's going on with our packet at all. We just know we can't get to where we want to go. So we want to make sure we do another ASP drop capture but including our NAT IP. So we're going to do the same type capture that we had before. We're going to make sure we have that NAT translation included. So at this point, we've kind of covered all of our grounds. When we go into testing, there's no way we're going to miss this traffic. We will see exactly what's happening, why we can't get where we're trying to go, from at least the firewall's perspective. So now that we covered all those, I do want to show you guys what this looks like in the show cap. So when we do show cap, on the ASP, as you notice, we have our private and we have our public here. With both of these, you might be asking, Megan, why didn't you just make a separate ASP drop capture and call it like ASP1 and have both of them saved under a different capture? Well, sadly with ASP, this is kind of a limitation we have. We only allow one ASP drop capture to be running at a time. The way around it is, what I did is we just call it the same name and it matches for these two different arguments. However, they get saved under the same packet capture. It's not necessarily a big deal in this scenario because we are capturing for why this type of traffic's failing, so it's all relevant to each other. Here's what our ingress packet capture looks like. It's just gonna have our private and then our egress with our public. So now that we got all our packet capture set up, we just got one more tool we're gonna go over. And that is system support trace. Just like packet captures, system support trace is going to be the live logs that are communicated across the network. We need someone there live to be able to do this. There's a lot of difference between system support trace and packet captures, but why I love system support trace is it will match your arguments and show you exactly what rule you're hitting. It's really helpful to help prove whether a packet is hitting a certain access list, or like, let's say we're pre-filtering traffic too. We can see if that traffic is actually going through the firewall with a pre-filter. It tells you exactly what access rule is hitting, and it helps really verify that our traffic is hitting the rules we want it to. The negative side of this is only configured in the CLISH. So I am very sorry for our ASA image people out there, but this is not a command we can run on the ASA. It's only for our firepower image devices. With that, let's go ahead and kind of show you what this looks like on the CLISH. So from the CLISH, we're going to do system support trace. From there, it's going to ask you if you want to enable debugs. I'm a big believer if I don't know what's happening, I definitely want more information. So I'm saying yes to debugs. I want as much information as it's going to give me because I have no idea why my traffic's not working. From there, it's going to specify port. I'm going to do TCP. We're still going to put my workstation's IP. Since I don't know my exact client port here, we're just going to bypass this and move forward and put in our server IP, which is Cisco's IP. From there, we're just going to specify our port 2, which is 443. I do note too that with system support trace, this is bidirectional as well, meaning I could switch client and server and it would work just the same, and we will see that traffic too. Also note that you don't need to put really anything here except a single IP. You can leave all of this blank. Why I would advise against this is that there's no way to redirect this, and it's like a debug. It will immediately start spitting out information on your CLI until you hit Control-C to stop it. However, let's just say you run it and you're not getting any information you want. Like if I ran it like this and I wasn't getting the hits, I would recommend just slowly removing some of the arguments until you start to see what you want. The good thing too is that if you're not logging a PuTTY session or an SSH session, this does get saved within the Linux mode of the firewall and the messages. And I do have some hidden slides if you guys want to go take a look at that kind of shows you how to find those because they're kind of hidden with all the other messages that the firewall gets. Okay, we covered a lot of information really quickly. However, we're going to start troubleshooting together, guys, because the overall problem that I'm having is I cannot connect to Cisco.com. So we have all of our rules ready, so let's go ahead and see what's going on. So we're going to start with packet tracer. I'm only going to show you guys some outputs of phases here. So we're going to focus on phase 3. The reason why I want to highlight phase 3 is that we can see right here our next hop is my default gateway to the outside. And the reason why I want to pinpoint this is that I actually recently, a week before Cisco Live, had a case when we saw right here that it was not going out the interface they thought it was. And we looked and saw it was a static route problem. So this is a really good way to verify that the packet's moving the way you want it to move. So this scenario, I'm seeing that my packet is entering my firewall and it's redirecting it to the outside. So this kind of makes me feel like it's not a routing problem at this point because it seems to be moving the way I think it should be moving. So let's highlight phase 5 now, which is going to be our access list. And as we can see in the big red right here, we're having a drop. Now, this is probably when we're getting some red flags going on that most likely we're getting dropped due to an access list rule. However, as I said before, packet tracer is just a simulation. We want to make sure we fact check it with the packet captures just to see what's going on. Let's look at the results tab just to see exactly what's going on though here in the packet tracer. As you see, we're entering through the inside, we're leaving through the outside. However, our firewall is blocklisting the packet. So this is a very good indication what's probably going on here. So on the back of our minds, guys, we're just going to flag access list, most likely a problem. Let's look at our captures to see what our captures are saying. So we're going to do a show cap in. And with that, we see one-way traffic. We're only getting send packets. The reason why I want to highlight this is this allows me to see that with our topology, if we look back at our topology, we are sending the send packet, but we're getting no replies, which basically means anything from my workstation to the firewall is not the problem. That's not what's going on here. We're not getting those replies, which means the problem now stems from my firewall out to the internet. But is it even leaving the firewall? That's an important question we need to know. So let's look at the show cap out. With our show cap out, we have 0 packets captured here, which can mean 3 things. 1, we configured the packet capture wrong, but all of you guys helped me configure that packet capture. We're all smart individuals, and that's not what happened. 2, it's not leaving through the outside interface, it's leaving through another interface. Well, with our packet tracer, it said it was supposed to leave through the outside interface, and that's how our traffic seems to be flowing, so I don't think that's the problem. So 3, where do drop packets sit? It's the ASP. So we definitely have configured an ASP drop capture, so let's see if that's where our missing packets reside at. And there we go. There's our missing packets right here. And as we can see, it's that same error code that populated in our packet tracer. It's the blocked or blocklisted by the firewall. So at this point, I feel very secure in the fact that our traffic's being blocked due to an access list. I could just go to the FMC at this point and randomly guess what rule is dropping it, but why would I do that when I have a rule? So let's go ahead and do the system support trace to see exactly what is happening. I will note, system support trace, I cleaned it up a lot for you guys. It's a lot of output when you run it, but I have parsed it so it looks much nicer. So I don't want to, give you guys the unrealistic expectation. It's really easy to read immediately. So with our system support trace, we have right here, it's saying it's match rule order 5. I will note this is also misleading because rule order 5 does not mean that's the rule in the FMC. However, the name is exactly what it is in the FMC. So we're hitting the Cisco live block rule, which the action is to block. This is a deny action. Or in an excellent input, we can see really more what the firewall is reading. We're seeing that it's pending whether or not to drop this packet. And the final verdict is it's blocklisting this packet. It's deciding now we're going to block this packet. So now that we have this kind of arranged, and we're pretty sure Cisco live block is what's happening here, we're going to go to our FMC together and take a look. So I'm our network admin here, and I kind of know what this block rule is, and I know I should not be hitting it. So we're just going to figure it out together, guys. So we're going to navigate to our FMC. This rule number 2 is our block, and this is going to be any inside to outside packet using a private IPv4 of 192.168.0.0. So yes, my IP is in that range, but a rule above it should allow me, and only me, my network admin, out to the internet. I want no one else in my network to have 443 internet access to the outside. But let's look at this rule because for some reason I'm not hitting that first rule. So when we look here, you know what, guys? I see what the problem is here. So 192.168.0.10 is not my IP. I don't know who that is, but they've been getting a free ride to the internet. And, they got to look at all the Cisco Live stuff, apparently, other than me. But, yeah, my IP is 192.168.0.11. So, I'm just going to come over here real quick and fix it, Let's go to our FMC here. And there we go. We're all good. We're all green, all happy. So 192.168.0.11, the box is a little off, but that's okay, is my IP. And we're going to save and deploy. Now, I want to let you guys know, at this point, I should feel very confident that I fixed my problem. However, if I do this deployment and it doesn't work, good thing is we have everything set up already. We just need to run through that again to figure out what's going on. We're making progress forward each time. So I want everyone, we're going to cross the fingers, we're going to hope, we're going to do a deployment and see what happens. And, a little drum roll. And look at there, we have access. So this might have seemed like a very simple problem, but typos happen all the time. We're human, and as I said, there's a lot of things to this firewall that could be. The reason why I wanted to go over all these commands with you guys is that could be like a guidebook for you guys to help troubleshoot these traffic problems. Throughout the month and a half or so that I was making this presentation for you all, I always had it up on my screen, which is really fortunate when I was taking cases with customers because they would run into traffic problems. So I was like, well, let me just run through my PowerPoint with them and see what's going on. Note, I have so many other commands listed and other troubleshooting things that TAC does in hidden slides. So please download this PowerPoint. Let this be your troubleshooting guide to this. And the reason why I want you guys to do this is that if you guys could get this output and provide it to TAC, it leads to quicker resolution times. I don't mean maybe leads to quicker resolution times. It does. We have everything we need immediately to look at. We might not immediately have the solution, and you might need additional troubleshooting after that initial process, but this allows us to create a good action plan moving forward.